The world's best codebreakers have spent over a century on this manuscript and walked away with nothing. Military cryptographers, linguists, and now AI models trained on hundreds of languages have all hit the same wall. Then a small team ran statistical translation software built for real living languages against its pages anyway. What came out was not a translation. The book that shouldn't exist. Walk into Yale University's Voynich Rare Book and Manuscript Library and ask to see MS-408, and the staff will bring you one of the strangest objects in academic custody anywhere on Earth. It is a small book, roughly the size of a modern paperback, bound in plain vellum. Open it and the first thing you notice is the pictures. Strange plants that match no known species. Naked women bathing in circular pools connected by tubes. Astronomical diagrams and zodiac symbols. A series of circular rosette diagrams that look vaguely cosmological. Rows of jars that suggest a pharmacy. A final section packed with dense text arranged in lists. Then you notice the writing. It runs across every page in a flowing, confident hand, covering text in a script that no trained linguist, no cryptographer, no historian, no computer scientist anywhere in the world has ever verifiably translated. Not one word, not one confirmed sentence. 600 years of silence from a book that was written by someone who clearly knew exactly what they were writing. The book is named after the man who brought it to modern attention. Wilfred Voynich was a Polish-born rare book dealer with an extraordinary life story. Arrested for revolutionary activity as a student in Moscow in 1885, imprisoned in the Warsaw Citadel, sentenced to Siberian exile, escaped through Mongolia, made his way across China to Germany, where he sold his last possessions, including his eyeglasses, to pay for a ship to England, eventually becoming one of the most respected rare manuscript dealers in the world. In 1912, he was invited to examine manuscripts for sale at Villa Mondragone, a Jesuit college outside Rome. Among the dusty chests of books, he found something that stopped him. He later described it as an ugly duckling, a small volume unlike anything he recognized. He bought it immediately. In the years that followed, Voynich tried and failed to sell the manuscript, probably because of his asking price, which reportedly reached $100,000. He died in 1930, still holding it. After passing through several more hands, the manuscript was donated to Yale's Voynich Rare Book and Manuscript Library in 1969. It has stayed there since, catalogued as MS-408, its digital pages now among the most frequently viewed items in the library's entire online collection. The physical object itself has been rigorously tested. In 2009, researchers at the University of Arizona's Accelerator Mass Spectrometry Laboratory radiocarbon dated 4 separate samples of the vellum. The results were consistent across all 4 samples. The material was made somewhere between 1404 and 1438, with 95% confidence, placing the manuscript firmly in the early 15th century, the early Renaissance period. Chemical analysis of the ink confirmed medieval formulations consistent with that era. The pigments used in the illustrations, including azurite and copper-based colorants, match materials used in early European Renaissance manuscripts. From every physical standpoint, the manuscript is exactly what it appears to be, a genuine book from the early 1400s. The question of what it says is an entirely separate matter. The 6 sections nobody can read. Historians studying the manuscript have organized its pages into 6 sections based purely on the illustrations, since the text provides no guidance. The sections are not formally named by the manuscript itself, which gives no headings or chapter markers. The names come from researchers trying to impose some order on the confusion. The botanical or herbal section is the largest, running through the first part of the manuscript and showing page after page of plants. The plants are detailed, carefully drawn, and entirely unidentifiable. Botanists have spent considerable effort trying to match the illustrations to known species, including both European and New World plants. A handful of partial matches have been proposed over the decades, but none have convinced the broader scholarly community. The plants in the Voynich manuscript appear to be composite figures, combining features from multiple real species or depicting species that do not exist. The astronomical section contains circular diagrams featuring stars, zodiac symbols, and what appear to be calendar markings. The zodiac signs are recognizable in their general form, though some details differ from standard medieval representations. This section has attracted attempts by astronomers and historians of science, none of whom have produced a verified reading. The biological section is the one that tends to generate the most fascinated reactions from people encountering the manuscript for the first time. It shows dozens of small naked female figures bathing in pools and tubes of various shapes, connected by elaborate pipe systems. The women are rendered in a consistent stylized manner. No scholar has produced a convincing explanation for what this section represents, with theories ranging from alchemical processes to bathing rituals to anatomical diagrams. The cosmological section contains large circular diagrams that some researchers have called rosettes, complex geometric figures that appear to represent some kind of spatial or cosmological map. One page folds out to a large multi-panel diagram, one of the largest pages in the manuscript. The pharmaceutical section shows what appear to be containers, jars, and plant parts arranged in ways reminiscent of medieval recipe books or herbals used in apothecary practice. The final section is dense text arranged with small star-like markers between paragraphs, suggesting a list structure of some kind. Many researchers have guessed this might be a recipe section, but no recipe has ever been read. Running through all 6 sections is the script. It uses an alphabet of roughly 20 to 30 distinct characters, depending on how ambiguous glyphs are handled, in a writing system scholars call Voyniches. Modern handwriting analysis has identified at least 5 different hands in the manuscript, meaning multiple people contributed to its writing. The script flows smoothly with almost no visible corrections, suggesting the scribes were fluent in whatever system they were using. Words follow strict internal rules about which characters can appear at the beginning, middle, or end, a structural feature consistent with natural human languages. When the world's best codebreakers gave up, the manuscript's history of resisting expert analysis begins long before the modern era, but the most impressive chapter in that history involves some of the most capable cryptographic minds of the 20th century. William Friedman is one of the most consequential figures in the history of cryptology. He is the man who led the American team that broke Purple, Japan's most sophisticated diplomatic cipher, in 1940, a cryptographic achievement that provided the United States with intelligence that shaped the Pacific theater of World War II. His wife, Elizabeth Friedman, was herself a pioneer in code breaking, working to decrypt Nazi spy communications during the same war, and described by some historians as America's first female cryptanalyst. Together, they represented arguably the most formidable code-breaking partnership of their era. Both of them studied the Voynich Manuscript extensively. Neither ever produced a solution. In 1951, William Friedman introduced the manuscript to John Tiltman, a British intelligence specialist who had worked at Bletchley Park, the wartime code-breaking center where Alan Turing had famously cracked the German Enigma cipher. Tiltman studied the manuscript closely and came away without a translation. He became something of an informal coordinator for ongoing scholarly efforts, passing the problem to the next generation of researchers when he could not solve it himself. NSA cryptologist Prescott Currier later made one of the few genuinely productive contributions to Voynich scholarship during this period. Working with statistical analysis of the text, Currier identified what he called 2 distinct languages or dialects within the manuscript, designated Currier A and Currier B, based on measurable differences in character frequencies, word patterns, and their distribution across the different sections of the book. Currier A appears primarily in the herbal section, while Currier B dominates the later sections. This finding is held up under modern computational analysis and remains one of the more solid facts known about the manuscript's internal structure. Currier himself never cracked the meaning behind either dialect. By the time this first wave of professional analysis was finished, the Voynich manuscript had defeated a group of codebreakers who had collectively cracked some of the most sophisticated military cipher systems in history. That track record established the manuscript's reputation as something genuinely difficult, not a puzzle that had simply not yet attracted the right person. It set the bar for anyone who came later extremely high. The statistical evidence that refuses to settle anything. While the high-profile code-breaking efforts were producing no solutions, a quieter tradition of statistical analysis was building up a body of evidence that is genuinely fascinating and genuinely inconclusive in equal measure. The most significant statistical finding about Voyniches is that it follows Zipf's law. Zipf's law is a mathematical relationship observed in every known natural human language, describing the relationship between how frequently a word appears and its rank in a list of all words ordered by frequency. The most common word in a language appears roughly twice as often as the second most common, 3 times as often as the third, and so on. This produces a characteristic curved line when plotted on a graph. Every natural language produces this curve. Random gibberish does not. Voyniches does. This single finding keeps serious linguists engaged with the manuscript, because it means the script is not random noise. Something systematic produced it. The same studies that established this finding also measured the manuscript's information entropy, the mathematical measure of how predictable or random a sequence of characters is. Random text has high entropy because any character can follow any other with roughly equal probability. Real languages have lower entropy because grammar and meaning constrain what can come next. Voynich's has low entropy, placing it in the range of real languages rather than random sequences. In 2013, physicist Marcelo Montemuro and mathematician Damien Zanet published a study in PLOS One that added another layer to this picture. They found that Voynich's exhibits what they called thematic clustering or burstiness. Words carrying the most information tend to cluster in specific sections of the manuscript before disappearing, exactly as you would expect if different sections of the book were covering different topics. If that kind of finding is what keeps you watching, subscribing is how you make sure the next piece of this story reaches you, because this pattern is found in natural language texts and is not easily produced by a mechanical process generating random-seeming output, which means the hoax theory has a much harder problem to solve than most people realize. Taken together, these statistical properties constitute a genuine argument that something meaningful is encoded in the manuscript. They are also, frustratingly, the same properties that a sufficiently sophisticated hoax might accidentally produce as a side effect of its own structure. Both conclusions are supported by the same data, and researchers on both sides of the argument can point at the same numbers and walk away with opposite convictions. The hoax theory and its unsolvable problem. In 2004, senior lecturer Gordon Rugg at Keele University proposed a theory that reframed the entire debate. Rather than asking what the manuscript says, Rugg asked a different question. Is it possible to produce text that looks statistically like a natural language without any of it meaning anything? His answer was yes, and he demonstrated a method. A cardan grill is a piece of cardboard with holes cut into it. Place it over a table divided into columns, with each column containing word fragments, prefixes in the first column, stems in the middle, suffixes at the end. The holes in the grill reveal one fragment from each column. Write down the combination. Slide the grill to a new position. Write down the next combination. Repeat this process, and you generate word after word that looks structurally consistent, because each fragment stays locked to its grammatical position, without any of it carrying meaning. Rugg published his paper in the journal Cryptologia in 2004, arguing that the unusual word-length distribution of Voynich's, which is very close to what mathematicians call a binomial distribution, could arise naturally from this kind of mechanical generation process. He followed this with a 2017 paper, co-authored with Gavin Taylor, also in Cryptologia, demonstrating that the quantitative statistical features of Voynich's can also be replicated using the same low-technology approach. The problem with Rugg's theory is not the method. The method works. The problem is the timeline. Girolamo Cardano, the Italian mathematician, published the first documented description of the grill device in 1550. The vellum of the Voynich Manuscript was made between 1404 and 1438. The gap between these two dates is more than a century. The tool Rugg's theory requires for its proposed hoaxing method was not documented until more than 110 years after the physical material of the manuscript was created. Rugg has two responses to this objection. The first is that an earlier undocumented version of the grill concept could have existed before Cardano published it, and that this version was simply lost to history. The second is that someone could have written on genuine old vellum decades after it was produced, using old stock that happened to date to the early 1400s. Neither explanation has been proven. Neither can be proven or disproven with current evidence. Both require accepting something for which there is no direct evidence in order to rescue the theory from a timeline that does not fit. This leaves the hoax hypothesis in the same position as every other Voynich theory. Interesting, suggestive, partially supported by evidence, and blocked from full confirmation by something it cannot get past. The I claim that collapsed in days. In January 2018, natural language processing researcher Greg Kondrak and his graduate student Bradley Hauer at the University of Alberta published a paper in Transactions of the Association for Computational Linguistics. Their approach was methodologically interesting. Rather than trying to read the text directly, they built an algorithm to first identify what language the manuscript might be based on. They fed samples of the Universal Declaration of Human Rights, translated into 400 different languages, into their system, looking for statistical patterns in Voynich's that aligned with one of those language samples. Their initial hypothesis was that Arabic would emerge as the closest match. Instead, Hebrew came back as the most likely candidate, a result Kondrak described to reporters as surprising. From there, Kondrak and Hauer proposed that the words in the manuscript might be alphagrams, scrambled versions of real words with their letters rearranged. They ran 80% of the tested words through a Hebrew dictionary and found matches, which seemed to support their hypothesis. Then came the part that fell apart. To actually read a sentence rather than identifying individual words, they needed a Hebrew scholar with expertise in medieval Hebrew. They could not find one willing to collaborate in time. Instead, they used Google Translate. Google Translate is trained on modern Hebrew. The Voynich Manuscript, if it is connected to Hebrew at all, would reflect a medieval form of the language, very different from what a modern translation tool understands. The sentence Kondrack and Hauer extracted from the manuscript's opening read, roughly translated, "She made recommendations to the priest, man of the house, and me, and people." Kondrack acknowledged to reporters that even according to a native Hebrew speaker they had consulted, the sentence was not quite coherent. The backlash from medieval scholars and cryptographers arrived within days. Damian Fleming, a medievalist at Indiana University, publicly criticized the decision to use Google Translate to interpret a potentially medieval text. Cryptographer Alanka Dunin raised a separate methodological objection. The AI had been trained on ciphers that Kondrack and Hauer had created themselves, not on real historical ciphers, meaning it had essentially learned to recognize its own scrambling patterns rather than something inherent to Voynich's. She described the leap from that result to identifying the manuscript's language as a big, big leap. No Hebrew scholar subsequently validated the finding. The claim quietly disappeared from scholarly discussion without ever being independently reproduced. The university that pulled its own announcement. In May 2019, approximately 16 months after the Hebrew hypothesis collapsed, the University of Bristol issued a press release announcing that one of its researchers had cracked the Voynich manuscript in just 2 weeks. The researcher was Dr. Gerard Cheshire, described as a research associate at the university. His paper, published in the journal Romance Studies, claimed the manuscript was written in a previously unknown language he called Proto-Romance, a form of Latin that predated the modern Romance languages like Italian, Spanish, and French. CNN and the BBC ran the story within hours. The internet lit up with headlines declaring the mystery finally solved. The backlash arrived faster than it had for the AI study. Lisa Fagan Davis, executive director of the Medieval Academy of America and one of the foremost authorities on medieval manuscripts, responded publicly and directly. She had encountered Cheshire's ideas before his journal paper, had tried to reproduce his method, and described what she found. When you apply his Roman letter substitutions and then try to translate the result, you have no choice but to be subjective. It's gibberish. She later described his proto-romance theory as not a thing. By the time of the 15th century, when the manuscript's vellum was created, Proto-Romance as a spoken language had not existed for centuries. All the actual Romance languages were already clearly developed. Cheshire's theory required a language that history provides no evidence for at the relevant time period. The University of Bristol removed the press release from its website within a single day. A university statement clarified that Cheshire's research was entirely his own work and was not affiliated with the university's medieval studies program. The journal Romance Studies, which had published his paper, is a legitimate peer-reviewed publication, but one without an impact factor, meaning it sits outside the highest tier of scholarly scrutiny. No external scholar subsequently validated Cheshire's translation. The paper remains published. Its conclusions remain unverified. The back-to-back public collapse of 2 high-profile claims within roughly a year of each other did something lasting to the culture around Voynich research. Publicly claiming a solution became a reputation risk rather than a career opportunity. Established academics began keeping their distance from loud announcements, while quieter, more careful statistical and codicological work continued in the background. What the pictures might be saying. Setting the text aside entirely, the illustrations in the Voynich manuscript have their own body of scholarly interpretation, some of it more defensible than the translation attempts. The botanical illustrations have attracted the most sustained expert attention. The plants in the herbal section are detailed enough to analyze, but do not match known European species. One long-running theory connects some of the illustrations to New World plants, specifically suggesting that certain drawings resemble species like the sunflower that were unknown in Europe before the late 15th century, which would complicate the timeline established by radiocarbon dating. The majority of botanists who have examined the illustrations conclude they are composite or imaginary figures, consistent with a tradition of alchemical herbals from northern Italy that depicted symbolic rather than scientifically accurate plants. The zodiac section has attracted attention from historians of astronomy. The zodiac signs are generally recognizable, but with specific differences from standard medieval representations, including some that resemble artistic conventions associated with northern Italian manuscript production in the early 15th century. consistent with the physical evidence pointing to an Italian origin for the book. The biological section has generated speculation ranging from alchemical diagrams to bathing ritual documentation to anatomy, but no proposal has gained wide acceptance. The consistent style of the female figures and the elaborate piping systems have resisted all confident interpretation. What the illustrations collectively suggest is a book created for a specific purpose, by someone who knew that purpose, for an audience that understood the context. Whether that purpose was medical, alchemical, religious, or something outside those categories entirely, the pictures do not reveal clearly enough on their own to settle the question. They are not random. They are organized and deliberate. They point toward meaning without delivering it. What the honest answer looks like after the wartime codebreakers walked away, after the AI claims collapsed within days, after the university press releases were pulled overnight, after a century of amateur and professional attempts produced nothing that survived independent scrutiny, the honest state of knowledge about the Voynich Manuscript is exactly the same as it was when Wilfrid Voynich pulled it from a chest in a Jesuit library in 1912. Nobody knows what it says. Nobody knows who wrote it. Nobody knows whether it contains a language, a cipher, an artificial constructed system, or deliberate nonsense. Every single claim of a breakthrough has either failed to produce a full, independently verifiable translation, or has been directly refuted by experts, or both. The speculative reading implied by the title of this script, that the manuscript was never a language at all, is the most dramatic version of the hoax hypothesis, that whoever made this book was not encoding secret knowledge, but generating the appearance of knowledge. It is a coherent position supported by real evidence. Specifically, the statistical work showing the manuscript's quantitative features can be replicated mechanically, and the timeline complications surrounding the Cardan grill. It is not, however, proven. The same statistical evidence that supports the hoax reading also supports the genuine language reading. Researchers making both arguments point at the same data. What is certain is that the manuscript is a genuine 15th century object. Its vellum, its ink, its pigments, its binding, all of these are authentic. Something deliberate was done with this object. Someone spent considerable time and effort producing it. Whether that effort encoded meaning or mimicked meaning is the question that has defeated everyone who has tried to answer it definitively. Verdict here is what the evidence shows. The Voynich Manuscript, catalogued as MS-408 at Yale's Beinecke Rare Book and Manuscript Library, is a genuine early 15th century document radiocarbon dated by the University of Arizona in 2009 to between 1404 and 1438 with 95% confidence. It runs approximately 240 pages of vellum written in an unidentified script called Voynichese, containing roughly 20 to 30 distinct characters written by at least 5 different hands and accompanied by illustrations organized into 6 thematic sections covering unidentifiable plants, astronomical diagrams, bathing female figures, cosmological maps, pharmaceutical containers, and dense text lists. American cryptologist William Friedman, who broke Japan's purple cipher in 1940, studied it for years without success. British Bletchley Park analyst John Tiltman studied it without success. NSA cryptologist Prescott Currier identified 2 distinct statistical dialects within the text, now called Currier A and Currier B, a finding that is held up under modern analysis. Voynichese follows Zipf's law, has information entropy consistent with natural languages, and exhibits thematic clustering of high-information words, all of which are properties found in genuine human language texts and not in random noise. In January 2018, Greg Kondrak and Bradley Hauer at the University of Alberta published an AI study identifying Hebrew as the most likely source language and extracted one sentence using Google Translate that medieval Hebrew scholars did not validate. In May 2019, the University of Bristol issued a press release claiming researcher Gerard Cheshire had identified the language as Proto-Romance, which the university retracted within a single day following expert criticism from medievalists, including Lisa Fagan Davis of the Medieval Academy of America. In 2004, Gordon Rugg of Keele University published a paper in Cryptologia demonstrating that a Cardan grill mechanism could generate text statistically similar to Voynichese. The Cardan grill was first documented in 1550, more than a century after the manuscript's vellum was created. The manuscript remains unread. Every proposed translation has either failed independent verification or been directly refuted. Whether it contains genuine encoded meaning or was deliberately constructed to appear meaningful without being so is a question that has resisted every tool, every expert, and every methodology applied to it across more than a century of sustained effort. It sits in a climate-controlled room in New Haven, Connecticut, waiting for either a translation that survives scrutiny or a proof of hoax that solves the timeline problem, whichever comes first. If this is the kind of story that keeps you watching, subscribing means you hear about it the moment either of those things happens.